So we touched on this a little bit earlier, but let's go into more depth about the difference between the map and the flat map operation in Spark. And to illustrate this, we'll look at an example of counting up the occurrences of each word in a real book. So we'll do that right now. So to review, the map operation transforms one RDD into another using some function that you provide to it. And there's always this one-to-one mapping between the RDD you start with and the RDD you end up with. Every row in your RDD that you start with is going to result in one row in your transformed RDD when you're using map. So as an example, let's look at this. Let's say we start with a RDD that contains 4 lines of information, and each row of the RDD contains, a little snippet like the quick read. Next row contains fox jumped, then over the lazy, then brown dogs. Let's say we have this little snippet of code here that loads that up into a RDD called lines. And for some reason, we want to create a highly distributed, scalable job using Spark that converts things to rage caps. So we can pass in a function like this that will convert everything in that to uppercase and return that into a rage caps RDD. So map here in this example will take every single line of input data, convert it to uppercase, and return a new RDD where there is a one-to-one relationship between the number of input lines and the number of output lines. So we end up with the quick red fox jumped over the lazy brown dogs, but really, really loudly yelling at you, right? It's all capitals. Now, in contrast, flatmap can generate many lines from one input line, or 0 lines even. Sometimes you just might want to throw data away as it comes in. So let's look at this more interesting example. We start with the same input RDD called lines, but this time instead of converting it to rage caps, we're going to split it up into individual words. So we want to take an RDD of sentences or snippets of sentences and convert that into an RDD where each row contains a single word. So we end up with many more rows in our resulting RDD than we started with. So here's an example of how flatmap can do that. Now flatmap, instead of returning a single value in the function you pass into it, will return a list of values, and that list can contain any number of results or maybe even no results at all. So take a look at this. In this example, we're passing in this function, x gets transformed into x.split based on space characters. And what split does, if it's given a string, is it returns a list of strings that are delimited by the character you pass in. So basically this is saying I'm going to take whatever string you pass into me and give you back a list of strings that are separated by spaces. Okay? And then flatmap will take each element of that list that comes back and produce a new row out of it. So the resulting words RDD contains one row for every individual word, or more specifically every string that's separated by a space in the input data. Okay? So now we start off with 4 lines of data, but we end up with, however many words that we have in that data to begin with. So that's the main difference between map and flatmap. Map is a one-to-one relationship between the input data rows and the output data rows, whereas flatmap can have a one-to-many relationship, or a one-to-one relationship, or a one-to-none relationship, whatever is appropriate for what you're doing. And a quick note for people who are a little bit more advanced in Scala, you can also use the sum and none constructs in Scala to do a flat map as well. If you return sum and none, none will be interpreted as no values at all, kind of like returning an empty list. So there'll be examples of that later in the course. So to make it real, let's write a script that actually puts flat map into practice, and then it'll make a lot more sense. What we're going to do is count the words in a book, and just for copyright reasons, I'm going to provide the text of a book that I wrote, which is this book, but whatever. I'm giving you the text of it for free as part of the course as sort of an exercise in natural language data that we can mess with. So let's go ahead and write a script that uses flatmap to actually count the occurrences of each individual word found in this real book. Alright, so as before, I have 2 folders open up here on my desktop. One is the directory that we're working out of for the course, which for me is C Spark Scala, and then over here I have the folder that I downloaded all the course materials into, which for me is in my downloads folder under another Spark Scala folder. First thing to do, select the book.txt file, and if you preview it over here, you can see that it contains the text of a book I wrote that is completely unrelated to this course, but is just a source of a bunch of text data that we can play with. So let's go ahead and copy that and paste it into the C Spark Scala folder that we're working out of. Alright, next we're going to start up the Scala IDE. Make sure we're in the correct workspace, which should be the same folder that we're working from. And open up the Spark Scala course project, go under source, and the com.sundogsoftware.spark package, which contains all the code we've written so far in this course. So let's right-click on that package and say import from the general file system. And now we'll select the course materials folder, which for me is going to be under downloads Spark Scala. Hit OK, and you should find in here wordcount.scala. Select that and import it into the project, and let's take a look at it. So let's double click on wordcount.scala and examine the code. Very simple. We're just trying to illustrate the use of flatmap instead of map, and it's going to be pretty much what we talked about in the slides here. So as usual, we have the usual code here for declaring our package name and importing the libraries that we need from Spark and log4j. We're going to call this object wordCount, and its main function sets the error level like we always do for logging, and then we create a Spark context, much like we've done before. Again, running locally in this example using all CPU cores named wordCount. Now we're going to input the entire book into an RDD called input on this next line. And the way it's structured is that there's actually one paragraph per line. So every row of the input RDD is going to contain one paragraph of text from that book. But what we're trying to do is get a count of how many times each word appears in the book. So that's what we do here with flatmap. So just like in the slides, we're calling flatmap on the entire text of the book, where every row represents a paragraph, and passing in this function that splits those paragraphs up by space characters, giving us more or less a list of words that are in that paragraph. So this returns a list, and every element of that list becomes a new row in the words RDD. So flatmap is breaking every paragraph out into individual words and taking every word in that list and creating a new row in a new RDD that we're calling words. So now we can use our friend count by value to count up how many times each distinct word appears in that words RDD, and then we will just print out the results from that by applying printline to each element of the final word counts result that we got back from count by value, which is just a dictionary of words and how many times they occurred. So let's give it a try. Go to run configurations. We're going to make a new Scala application, and this is going to be called word count. And its main class is com.sundogsoftware.spark.wordCount. Let's run it and see what happens. Off it goes. So pretty cool. Hey, it actually worked. So, you can see through here, it's sort of a list of words that appeared. And for example, the word physical showed up 17 times in my book. The word commute only showed up once. What are some other popular words in here? Of course, that's a common word, 1,176 times in this book. But if you look at this, you can see that there's some issues with our results, right? So first of all, they're not sorted. It's not a very useful piece of output here because I can't really see what are the most common words very easily. Another thing is that there are punctuation included in these words. So we're only splitting on space characters. So for example, row comma is counted as a different word than just row. Or it might be a different word from row period, right? So that's an issue we should address. There's some sort of special Unicode thing going on here, I don't know, in Minimal. That's not being dealt with properly either. And the other thing too is we have different capitalization. So for some reason, I have the word ideas in all caps. It's probably some section title, but that's going to be counted as a different word than lowercase ideas. So there's a lot of room for improvement in this script, and that's what we're going to do in the next couple of lectures, kind of explore ways to take this basic implementation of counting up the words in a book and making it into something more and more useful over time by making it a little bit more complex. So let's do that in our next lecture.